So I'm going to unshare my screen now, and Gary is going to share his, and he's going to talk to us about some really fun weather. Let's learn about
Oh,
the favorite kind of weather, what it means to be a station scientist.
well, I can tell you right now. Can you hear me fine?
Yes, we can.
Good deal. Good deal. Should I announce my favorite weather?
Yes, please. I would like to know that as well.
Severe clear. I'll take a blue sky, sunny day with temperatures in the 60s and low humidity any day of the week. I have to work. I get paid the same whether it's sunny out there or we're dealing with a hurricane or a snowstorm. So yeah, I'll take sunshine and 60s any day of the week. Now, when I was a kid, I would lean more toward active weather, but not now. Oh, by the way, my cat Wicket showed up, so she may make a guest appearance during this presentation.
Sounds great.
All right. Take it away.
Take it away.
Take it away. All right, good deal. Well, again, thank you for inviting me. This is very exciting. I wish it was in person, but got to do things differently when there's a pandemic. But again, thank you all for stopping by, and I hope you'll learn something from this, and it may spark your interest in meteorology or maybe even one of the other sciences that I talk about from time to time when I'm on television. So, what exactly is a station scientist? Well, let's first tell you what my real job is, which is covering meteorology, covering the weather. A little bit about me. I grew up in North Carolina, down in Harnett County. Got my degree in atmospheric sciences from the University of North Carolina in Asheville. I was a meteorologist at WLOS-TV in Asheville for 13 years. Came here in 2002 to be the chief meteorologist at what was News 14, then was Time Warner Cable News, then was Spectrum News, now it's Spectrum News 1, coming up on my 19th anniversary next month. I'm a licensed pilot, commercial multi-engine rating since the 80s. Got 2 grown children, been married for almost 35 years. I'm the grandfather to 3 cats and 1 dog, and the parent to 2 cats, and Wicket left, so she's not going to make an appearance this time around, so we'll save that. My family, my wife's a pharmacist, so we got 2 scientists in the family, so we have some very interesting conversations. My son is in law school over at Carolina. My daughter works in the film industry over in Nashville, Tennessee. Like I said, they're both married. There's Wicket and Snowball. Wicket's the one looking down over the rail at me, and Snowball's the one there looking very eclipse-like in the sun. Speaking of being a pilot, yeah, I got my pilot's license in '85. The guy I'm standing next to in the other picture is my flight instructor back in the '80s. So I learned to fly down in Harnett County. One of the things that sparked my interest in science was when I was growing up, the Apollo program. We had a space program that was full bore heading to the moon. And I remember being 6 years old and watching Neil Armstrong walk on the moon on July 20th, 1969. And that was one of the most vivid memories from that time that I can remember. As a matter of fact, it sparked my interest in me actually wanting to be an astronaut. And for all it's worth, believe it or not, TV played a role in it as well, because 2 characters in 2 television shows actually also led to my interest in science. The professor from Gilligan's Island, please tell me everyone has seen Gilligan's Island, and of course, Mr. Spock from Star Trek, because these guys were the ones solving the problems. And I'm like, how cool is it for people to come to you because you are the one who has that knowledge that can solve those problems and help people and make things right. And to be honest with you, I think everybody who's a scientist, no matter what kind of science they're in, that's one of their main reasons that they want to get into science. It's because they want to help. And every science, people help. So first thing off, meteorologists do not study meteors. They're fun to watch. They're fun to see meteor showers, but no, we do not study meteors. So why a station scientist? Why is a meteorologist considered a station scientist? Well, when you think of everybody who works at a television station, we're the only ones in the building with science degrees. You've got people who have degrees in broadcasting, in journalism, political science. But when it comes to actual science, the only ones who actually have studied science are the meteorologists. And this lends itself to us having the responsibility of having to explain any science event that's going on, even though it may be outside the field of meteorology. Um, Basically, what a station scientist is a person who has just enough knowledge of those other sciences that we can explain something that's going on outside the realm of weather and meteorology. Some of the things that I have covered as a station scientist, one of my favorites is space science and space flight. I've covered a lot of things when it comes to space travel. Astronomy, seismology, earthquakes. If you recall, earlier this year, we had the earthquake up along the North Carolina-Virginia line. Well, our meteorologists who were on duty that day were thrown into the mix, actually explain what kind of earthquake it was, why we felt it, where we felt it, which, by the way, I did not feel it, which I feel left out. Didn't feel the one that hit DC a few years ago either. So again, I feel left out. Medical, with the pandemic, um, I've actually had to jump in and do some medical stuff as well. And it really helps having a wife who's in the medical profession, because I've gleaned a lot of knowledge from COVID and the treatment of COVID and the vaccines and whatnot, because my wife's on the front line working with this right now. Ornithology, birds. I took a ornithology class when I was in college and hated every minute of it, and now I love bird watching and feeding the birds and identifying them and watching them. Interesting fact about the birds: if any of you have feed the birds, you know, right before a winter storm, you can't keep those bird feeders full, because the birds know the weather's coming and they will just clean you out. And I learned that when I was living up in Western North Carolina, because one of the ways Native Americans and farmers, way back in the day before we had the National Weather Service and the Weather Bureau and stuff like that and the internet, would watch nature to determine what the weather was going to do. So there's a fairly large Native American population in Western North Carolina. And I actually learned that when I was up in Asheville and up in Western North Carolina. Biology, one of the things about biology, well, when you get a freeze, why do you bring your plants in? Well, you have to bring your plants in because if the temperature gets cold enough, the plant cells actually freeze, break, and rupture. And that's what kills plants when it comes to a freeze in the spring or in the fall. Physics, yeah, got to deal with physics because of, well, part of astronomy as well. Now, I will say this: of all of those, the most popular thing that I talk about with the general public beyond meteorology is astronomy. That's why this talk is going to be focused more on astronomy and how I cover astronomy for the television station. Um, Again, covering space shuttle missions when we had those, fantastic. That was great. I remember very vividly covering the final mission of Atlantis on STS-135. Looking forward to covering more space missions as we get the Dragons flying and the Boeing Starship flying. I Actually, I'm going to hit the break right here, Martha. So if anybody has any questions up to this point, let's take them on.
Sure. So mostly we have just some comments on what you've been sharing. And one of our participants, Jed, mentioned astronomy is a #1 job, and then a storm chaser would be a second job.
Yeah, I will say this when it comes to storm chasing: don't watch the movie Twister and think it's going to be like that.
That's a good thing to make. Good point.
It's not going to be like that. It doesn't work that way. And if you're going to chase storms, you better know something about meteorology, or you're going to get yourself in some serious trouble. So yeah, if you want to go out and storm chase, make sure you got some training in meteorology. A degree in meteorology helps a lot. And like I said earlier, being a child of Apollo, yeah, I agree. Astronomy is awesome. And if I could probably make a living doing that, I'd do that. But no, there's more meteorology jobs than astronomy jobs right now.
And I think it's a fun just fun to realize that your job includes all of these different sciences. And that's a good reminder that science is interdisciplinary too. So,
Oh, absolutely, absolutely. The way, and the funny thing is, scientists, like I said, the way we are wired is one of the main reasons we get into it is to help. But it is amazing how the same thing that brings me to meteorology brings us astronomer to astronomy and brings a botanist to biology and so on and so forth. And it just really it's really amazing how science is, like you said, intertwined,
that's right.
and the same principles are involved no matter what the science is.
That's right. Thanks, Gary. You can, if you'd like to continue, go ahead.
Rock and roll. Again, one of my favorite pastimes is watching the birds and ornithology, and I love taking pictures of them. And some of the most popular things that I share on social media are my bird pictures. The suet that you see in the suet container there with the bluebirds, I actually make that myself, and the bluebirds love it. These were a daddy bluebird and one of three baby bluebirds that grew up in our backyard last spring, and they're back now at our feeders actually as adults, which is again super cool. Um, Again, being a pilot, um, a lot of stuff going on in the atmosphere, and you know what? If you're a pilot, you need to know what's going on. One of the reasons I became a meteorologist is because I'm a pilot, and I was really thinking what kind of degree would be best for being a pilot. And knowing what you're flying into and how to handle it, always a good thing. And I also love the effects sometimes that airplanes can have on the atmosphere. If you notice this picture, this is a CRJ jet going into RDU International. You see the little white wisp coming off that flap on your screen there. What that is a little vortice. It's basically a horizontal tornado. What makes an airplane fly is air flowing over the wing in the atmosphere. The way the wing is designed, you get high pressure below the wing, you get low pressure above the wing, and when that pressure equalizes as it comes off the wing, you can have some vortices, and that actually shows up when there's enough moisture in the air. And there's a lot of times that I can tell without even looking at maps how much moisture is in the atmosphere just by glancing up at an airplane that's flying over. By the way, I live near RDU, flying over the house, and I can tell how much moisture is in the atmosphere. Just observation. Um, like I said, space, astronomy, besides meteorology, top of my list. It's really on the top of people's list as well. Anytime I mention anything about astronomy, either on air or on social media, that is like one of the most beyond the cats. That is one of the most popular things that I tend to talk about and can explain to people. Um, every once in a while, you get a cool picture. And I shot that a few months ago with an airplane flying in front of the moon. And let me tell you, it's really tough to time something out like that. And you know what? Sometimes you just get to do cool things when you're in my job. Those of you who don't know this guy right here, that's Neil deGrasse Tyson. And let me tell you this: if you ever get a chance to hear the man speak, go hear the man speak. Um, I have tried to make meteorology like he makes astronomy. He makes it fun. He makes it entertaining. He is a class act. I mean, on the right hand side, the smile you see on his face, that was the entire evening. I got to introduce him over at Chapel Hill for a speech he gave, and again, just a wonderful man, and again, very very knowledgeable. And again, if you ever have the opportunity to hear, uh, uh, I highly recommend it. Now, looking back at me being a station scientist, one of the first things that I can remember beyond meteorology that I did as a station scientist was cover a lunar eclipse back in 1993. I actually did an interview with an astronomy professor. We were out at the quad at UNC Asheville, and we were watching this full eclipse. And that's the time that it really showed me that people were extremely interested in astronomy, not just me, but people as well. And the cool thing about that is when you know people are interested in it as you are, you got a connection right there. And that connection is great because not only are they looking at you for information on upcoming events or events that are happening, but they actually will communicate to you, asking questions. It's the reason you got to kind of study up and know exactly what's going on. Now, my first encounter with a comet was Halley's Comet in 1986. And I will tell you this, that was one of the most disappointing events I think I've ever seen. Because leading up to that, all I had heard was Halley's Comet, when it came by 76 years ago, it was spectacular. It had a tail that went across the sky. It was great. Well, because of the position of the Earth and the orbit of Halley's Comet in the spring and winter of 86, viewing in the northern hemisphere, southern hemisphere had a very better view. Well, guess what? We live in the northern hemisphere. I remember chilly February night, putting my telescope on it, and it was a fuzzy ball, and that was it. No tail, no nothing, just kind of like a fuzzy ball. It literally looked like a star that was out of focus in the telescope. I was more excited the first time I saw Saturn's moon, or excuse me, Saturn's rings in a telescope than I was seeing this once in 76 year comet. So yeah, that was highly disappointing. However, about 10 years later, and actually, you know what? I got this wrong. This isn't 96. This was in 1994, I believe. Comet Yakutaki. This is the days before the internet really got going. So we didn't have Facebook, we didn't have social media, we didn't have things where we saw where celestial events were going to happen like we do today. I was working the morning shift, and I stepped outside on our deck in Asheville, and I looked up and I saw like something with a tail all the way across the sky. And it was 3:30 in the morning. And I went and I woke my wife up and I said, "You're not gonna believe this. There's a comet outside." And my wife looked at me like I was crazy, rolled over and went right back to sleep. But I got to work and I jumped on the internet that we had back in that day. And sure enough, found out that we had a comet, Yakutaki. And the amazing thing about that comet is that the tail went halfway across the sky. And where we lived in Western North Carolina, we didn't have to really worry about light pollution. We could actually get to a place where we could actually see, celestial objects without street lights and field lights and stuff like that. And to see something like that for the first time, that's what I expected Halley's Comet to look like. And then Yakutaki was just absolutely incredible. And then to top that off, good old Comet Hale-Bopp came by in 1997. And Hale-Bopp was, well, like you can see in the picture, it was just amazing because it had the white tail and it had the blue tail on it. And literally, you just walk out the door and look off to the west just after sunset. Here was this bright, beautiful comet in the nighttime sky. And I remember building so many graphics and talking about the comet on air so many times over a period of about 1.5 to 2 months. And it was just to have something that spectacular for everybody to get out and see and enjoy. And again, re-emphasizing the love of astronomy and seeing those once in a lifetime events like that was just absolutely, it was great. It made me feel good to be able to bring that to them. And then also one of the most popular things that we have when it comes to astronomy is the meteor showers. If any of you remember 2001, the Leonid meteor shower was actually a meteor storm. I've never seen so many meteors flashing across the sky. They were nonstop. They were 2 at a time. They were 3 at a time. I actually saw one explode and literally was waiting to hear the concussion from it. But again, another thing that's super popular with when we're on air is telling people about the meteor showers. And we have the two big ones. We have the Geminids and we have the help me, Martha. What's the other one? The Geminids and oh, there's one in the summer and one in December.
Maybe I saw that Patrick was in here. Patrick, do you want to type into the chat and answer
Oh,
that in a minute? I'll let you know if somebody types it in. I know
okay.
which one you're talking about, but I haven't seen it yet.
Yeah,
I got that.
we got one that leans toward July and August, and then we got that one in December, and I think it's the Geminids that we have in December. So anyway, those are the two big ones. Every once in a while, we have one that will sneak in and give us a good show other times of the year. Another.
Sorry, really quick. One of our participants, Tina, said that she and her husband were fortunate to see Hale-Bopp from the air.
Oh, wow.
That's pretty cool.
That would be, can you imagine seeing something like that from orbit?
Yeah.
I mean, that would have been, and I have to tell you this, we just passed the 35th anniversary of the loss of Challenger. One of the things that was, again, kind of compounded my reaction to Hale-Bopp or to Halley's Comet back in '86 is we had several shuttle missions lined up that were actually going to study the comet. And of course, Challenger on that mission as well was supposed to do that. So that not only such a tragic loss with the loss of the shuttle and the crew, but loss of science at that time as well. One of the cool things too that I still, it amazes me. We've had that space station up in space for 20 years. People are still amazed when it flies over. Yep, exactly. Nice, bright object. If you get, let me tell you right now, looking at the space station on a flyover, if you do it just after sunset or just before sunrise, that's when it's brightest. That's when you have the better angle of the sun. And if you can get one at that point, it is going to be absolutely spectacular, especially if it's a long duration pass between 3 and 6 minutes. That's when it's traveling closer to overhead. But to look up there, see that space station flying over and know there's people on it and that we built it. We were actually smart enough to build that thing. I will say this, some of the coolest times that I think when with the station seeing it is when we've had when we had the shuttle, and when the shuttle was either approaching to dock or had just left the station, because you'd see the space station go by and then you see the shuttle as a little smaller dot go by. But yeah, again, it's been up there for 20 years, but people are still absolutely amazed when that space station. When I tell them to go out, because they'll post on social media, "Oh, it was so cool! That was great! That was And so yeah, it's great that people still have interest, even though it's been up there for about 20 years. Now, and you know what? In the last few months, we've had some really cool astronomical events going on. The moon and Venus putting on a show. And then, of course, we had that big solar eclipse a couple of years ago. Everybody raise your hand if you got to see the eclipse. I didn't. I had to. You didn't? You didn't?
I got to go outside and see like the really strange lighting and see the shadows on the ground, but I didn't go somewhere where I got to see it in full. Yeah, I saw partial like Carrie. So.
Yeah, that was one of the things I was kind of disappointed at. I didn't get to go, but I did get to see a solar eclipse that passed over North Carolina, and that was back in the early '70s. And if you've never experienced a total eclipse, the way things get dark and the street lights pop on and the birds go into roosting and stuff like that, and the way the animals react. Now we've got another eclipse coming up. I know it's on April 8th because it's my son's birthday. Is it 2024?
I have 2024 because when I realized, that I really didn't plan anything for this past one, I was like, I'm going to see the next one. 2024, yes.
Yeah, because it's my son's birthday, we're already planning an eclipse party, so we got to get somewhere. Well, Buffalo, New York is going to be like ground zero for it. So we've been knocking around the idea of going to Buffalo. But you know what? If you get the chance to and always observe all the safety measures when you're watching one. You can't look at the sun and you can't look directly at the solar eclipse. Your eye doctor will get very upset with you, and your eyes will get upset with you as well. Always safety rules, safety first. And of course, we all know what really happened. It was really the Death Star going in front of the sun. If that doesn't really, shows the Death Star. By the way, that was a big hit on social media when I posted that as well back in 2017. 2019, cool total eclipse of the moon. It was 20 degrees outside, 2 o'clock in the morning. I'm in my driveway taking pictures. I just got to wonder what my neighbors think of me sometimes.
I'm sure they know now, right?
Well, never can tell. Of course, in 2020, we had comet Neowise. Pretty spectacular little comet, not quite as spectacular as Hale-Bopp. You had to know where to look to actually find it, but it was pretty neat. And of course, like I said, the planets Mars, Saturn, Jupiter putting on a show for us. And we had a couple of times where the moon got really, really close to Mars, or maybe Mars got really, really close to the moon. Then you get up close and personal with Mars. And then this was actually a surprise. I saw Jupiter and I'm like, I'm going to take a picture of Jupiter. And when I took it, I glanced at the picture and I'm like, okay, what are those dots? And I'm like, oh, wait a minute. I captured the Galilean moons, which there are 4 Galilean moons. And I think I got 2 in that shot right there. And then, of course, we had the Great Conjunction of 2020. I hope all of you got to see that. That was pretty wild. I was so ecstatic that the skies were clear and we could see that.
It
And
was really cool.
I'm sorry, what?
I was saying I was agreeing. It was really cool.
Yeah. I mean, I took that picture, and if you look close enough, you can actually see on either side of the dot on the left a couple of the Galilean moons, and of course on the right of that picture, that's Saturn. But my wife looked at me. She's like, "Why don't we go get the telescope?" And we got the telescope, and I really wish I could have gotten a picture of that where you could see all 4 Galilean moons. You could see Jupiter. You could see the rings of Saturn in that shot. But again, this was something that had it was 800 years, right, in the making. The last time it had happened. So just absolutely, absolutely incredible, the show that the night sky puts on. And again, a lot of interest from the general public when we had this great conjunction. Actually, you know what? Let me back up before I go to that slide. Has anybody got any questions at this point?
No, we just had some comments about others when they got to go see the eclipse, and everyone's enjoying your stories of the things that we've been able to see in the sky. And it's fun to hear that you also get to talk about things besides the weather. I have to admit that I always think of you just talking about, not you, but a meteorologist talking about the weather. So it's cool that you get to talk about all these really fun, interesting things.
Well, and that's one of the things too. I mean, it's like your job. You've got a normal routine.
That's right.
When you get a break in that routine and are able to do something else, it does. I mean, I will be honest with you. Sometimes the weather gets monotonous, and it's like I'm saying, like in the summer, hazy, hot, and humid with a chance of afternoon thunderstorms. It's like there's only one way to say that: hazy, hot, and humid with a chance of afternoon thunderstorms. So when we have something like this that is happening, a space station flyover, or something cool astronomically going on in the sky, or something like that, it's a real nice break to be able to actually discuss that and talk about it and spark interest. Because I mean, just like my interest in science was sparked at a young age with the Apollo space program and with watching television. You never know when you're going to present something that sparks somebody's interest. And I think that's absolutely, that is probably one of the greatest compliments I think that any person can have. If you kind of steer a young person into the direction of a career, especially if they are going to enjoy that career.
Thanks,
Right.
Gary. And I do have a few questions now.
Okay.
So Tina wanted to know, what about the triple conjunction that happened after the Great Conjunction?
Oh, the one with Mercury and Saturn and Mercury, Saturn, and Jupiter.
I guess that must be what Tina means. Yes.
Yeah,
Did you get a picture of that?
I think that's what she's talking about. Because you know what, I would have loved to have seen that. But the problem is finding a place low on the horizon that you can see stuff like that is. But yeah, that was a cool one. I mean, I literally took the day off to do this great conjunction. I mean, I did. I said, I'm taking the day off. I don't care what's going on. If the skies are clear, I'm taking the day off. So I specifically took a day off so I could enjoy that. Even so, I couldn't do the same thing for the eclipse a few years ago. So at least I got the opportunity for doing this.
And then Hugo was asking about your job. So, what was the most dangerous moment that you've had to face in your job, and something you've never seen and would love to see?
All right. As far as the most dangerous thing, I would say in 1993, we had a blizzard in Western North Carolina. It was called the Superstorm. We had feet of snow. I learned to hate snow during that storm. We had anywhere from 2 to 3 feet of snow with snow drifts 4 to 5 feet deep at my house. Driving in that was terrifying. I got in behind the snow plow that was sliding all over the road, and I was just driving a 4-wheel drive Blazer. So, as far as danger, that right there was probably the most dangerous situation that I've dealt with. And I will be honest with you, there's a touch of irony what we have to do in television, like with winter storms. We have to get out in the winter storm and get on TV and tell you to stay home. So we're doing the opposite of what we're telling you to do, but we have to do that so we can get on TV. It's just like the winter weather we had Wednesday night, early Thursday morning. I drive a Mustang. Mustangs don't do well in snow. They barely do well in wet weather. And I got home that morning just before the snow started. And if I hadn't have gotten home when I did, I would have gotten stuck on the highways or possibly, ended up in a ditch or something like that. So that's one of the reasons why I hate winter weather. And I hate that people want to get out in it. It's like, stay home, enjoy it. Watch the birds at the bird feeder, watch the snowflakes falling. As far as something that I would want to see when it comes to space, I would say I would love to see a rocket launch. I hate that I never got to see a shuttle launch, but to see a rocket launch, I think would be super cool. To go up to the space station would be even super cooler. As far as weather, as long as it's not coming here, I would love to go to the coast and cover a hurricane.
Thanks, Gary.
Anything else? Any other questions?
No, I think we can keep going.
All right, we will soldier on.
Okay.
One thing that I have to do too is not tell people just what's going to happen, but what's not going to happen. And in the age of social media, it amazes me how many times things like this pop up. Like every 2 years, we see something that Mars is going to be the size of the moon on a certain date and at a certain time. Let me tell you right now, if we ever have a situation where Mars looks as big as the moon, we've had it. It's all over with.
That's funny.
Yeah. I mean, it really is. It really blows my mind how many times this pops up. I mean, think about it. If Mars were to look the size of the moon, then Mars would have to left orbit to get to us, or we would have had to have left orbit to get to it, or the moon would have had to have left the orbit of Earth and be heading off toward the moon, and it would be a dot out in the distance. And we do not want any of those things. But it continues to amaze me how many times people actually see this and actually believe it. And it's like, no. It's to be honest, if it wouldn't kill us, I think it'd be a cool thing to see. But the problem is it would kill us. So yeah, the gravitational influence that Mars would have if it drifted into our orbit or get close to us, or if our moon drifted away, yeah, not a good situation. So whenever you see this on social media, whoever posted it, tell them they don't know what they're talking about. and stop posting it.
They also need to change the words to say no one alive will ever see this.
Yes, absolutely. Yeah. Absolutely. Now, you know what? Interesting little tidbit. So, and you may or may have not heard this. We think the origins of the moon, speaking of Mars, for those of you who are not aware of this, they think the moon actually was once part of Earth. And we know this because of the samples brought back by the Apollo astronauts back in the late 60s and early 70s. So the theory of where our moon came from is that a Mars-sized object, when Earth was forming, hit the Earth, knocked debris from Earth out into space. Well, over millions of years, that debris continued to slowly come together and go into the orbit of the Earth, and it cooled over time and it became the moon. Now, another thing that that Mars-sized object did was it actually kind of put the Earth on a tilt of about 23 degrees on our axis. And what the moon does in its orbit is it holds the Earth in that 23-degree tilt. So if we were not permanently in that 23-degree tilt, we wouldn't have seasons. And if the moon wasn't there, we wouldn't be in that tilt permanently. So there you go. It took a Mars-sized object. So at one point, we saw something that big, or somebody on Earth. Well, nobody did. There was no Earth. There were no people at the time. But if you could go back in time, there was an object that size that was heading toward Earth. So again, I thought that was like one of the coolest things to have a sequence of events that actually made it possible to have life on Earth, which is just mind-boggling. But again, anytime you see that Mars is going to be the size of the moon in the sky, yeah, it ain't going to happen. All right, the other thing that I have to deal with from time to time, because I love taking pictures of airplanes, is this whole chemtrail mess. There is nothing. Yeah, the only chemicals in the contrail of that jet right there is water. That's it. That's exhaust. And every once in a while, I have somebody inform me that I'm hiding secrets, that there's chemicals being sprayed out the back of jets and airplanes and stuff like that in the atmosphere. Not exactly sure why we would do that, but yeah, I've had people get on me about promoting chemtrails. Well, that's a contrail, and on a side note, a contrail is actually a type of cloud. It is a man-made cloud, and it does actually impact the environment because it reflects solar radiation. And after the unfortunate events of 9/11 back in 2001, air traffic was grounded for the most part. So there was a lot of research done over that 3-day period of time when we did not have contrails in the sky to see how much that was actually impacting the environment, causing cooling effects and causing warming effects. So yeah, I mean they can impact the environment when it comes to weather to a certain extent. But like I said, the only chemicals coming out of there or whatever chemicals that went in the engine and came out the back that was already up in the atmosphere. But most of that just water vapor. All right. Two overused terms in today's world are supermoon. Raise your hand if you're tired of hearing the term supermoon, because good gracious, it's not that super. It's a little bit bigger, just by a little bit. And then the polar vortex. A couple of years ago, the polar vortex actually shifted and some colder air came down. Well, that was the first time that had happened since social media had come online. So everybody went, "Oh my God, polar vortex, we're all going to die." So it's like, I'm sorry, the polar vortex has been around here as long as, forever. As long as we've had an atmosphere, we've had a polar vortex. There's been one over the South Pole, there's one over the North Pole, and any planet that's got an atmosphere has got a polar vortex over the North Pole and over the South Pole. And I will say this, what's really interesting is some of the long-range models are actually saying that a lobe of the polar vortex is going to kind of wobble down toward the United States, the mid-Atlantic states. And if that does happen, it will get cold. But yeah, the polar bear is not going to come get us. So just FYI, when you hear polar vortex, nothing new. It's not mean. It's just get your heavy jacket. It's going to be cold. All right. And of course, there's the dreaded weather app. How many of you see a snowflake on the weather app and you go, "Oh my God, it's going to snow"?
Me.
Yeah, exactly. Exactly. Stop doing that. Stop doing that. Here's the bad thing about the weather app. And again, a lot of people depend on it. We as meteorologists look at a lot of models. The event that we had Wednesday night into Thursday morning, we had models ranging from 9 inches of snow in the triangle area to nothing when it came to wintry precipitation. Most weather apps that you get on your phone key off of one model. Meaning if that one model says there's going to be a snowflake, there's going to be a snowflake. But here's the other thing: what does that snowflake mean? Does it mean flurries? Does it mean an inch of snow? Does it mean 6 inches of snow? Does it mean a blizzard? Um, that's one of the things right there that people have to wonder when they see that. Now I'll give you an example. That snowflake on Thursday was actually right. We did get snow early Thursday morning, but we also had a snowflake that popped up just before Christmas about snow on Christmas Day. Well, at that point, everybody went, "Oh boy, white Christmas." No, we had about 3 snow flurries that fell across the area, and that was about it. I didn't even get to see one. So again, that's the danger of the weather app and the dreaded snowflake. I will say this: it's kind of like winning the lottery or thinking you might win the lottery. If you've got that lottery ticket, you're going, "There's a chance I might win that $100 million." So if you look at that snowflake, you're probably going, "There's a chance I may have snow on the ground on that day." So I think that's a lot of reason why some people gravitate toward that. By the way, for those of you who are in North Carolina who are interested about the possibility of snow tonight, yeah. Oh, Martha's excited. Let me tell you let me give you a quick forecast. Number one, it looks like it's going to maybe flurry a little bit this evening. And then as we go to tomorrow morning, it looks like more of a wintry mix that'll change over to all rain as we go through the day. If you live roughly I-85 north and west, back toward Greensboro, back toward Person County, back into western North Carolina, the mountains and foothills, you got a better chance of seeing some snow and ice. I think once you head a little farther to the east, central eastern North Carolina, you might see a dusting, you might see a light accumulation just before it goes over to all rain. So yeah, this one shouldn't be a big deal in much of central and eastern North Carolina, more western North Carolina. And speaking of which, let me see. Does my weather app actually have a snowflake for Sunday? Actually, it does.
So
It's got a snowflake for Sunday.
we'll have to ask you that later, Gary, what weather app you use.
Well, this is just the generic one that came with the phone.
That's right.
So yeah, this is the one that keys off one model. So yeah, I don't put much, whereas I think what I told you was going to happen, I don't put much trust in the average generic.
Good to know.
That's why we need that's why we need meteorologists. If weather apps were as accurate as people thought, then you wouldn't need a meteorologist because you can look at your phone and there you go. But we have to figure out exactly how much it's going to snow at somebody's house. Do you have a question popped up or a comment?
Oh, we're just yeah, we're just how often are weather apps updated is what Tina asked. And then I was going to ask you too about when the knowledge that you have as a meteorologist and like the knowledge that you use when you walk outside and look up at the sky and look at the clouds. Like, can you ever put the two together and be like, these things actually match today? This is what's going to happen.
Yeah, as far as the weather app, generally most of them, if it's the generic weather app, if it's a television station app like our Spectrum News One app, it's actually keying off of a meteorologist who's built that forecast. What we do is we actually put the information into our weather computer, and that weather computer fires it off to the app and keeps it updated. So yeah, there's eyes on that forecast. The generic weather app that you get with your cell phone, generally it updates about 4 times a day when that model updates, and that's why you see changes through the day. But again, it's also keying off one model as opposed to eyes on via a meteorologist actually, kind of forecasting the weather like we were doing. As far as like going out and looking, 2 things. Have you ever smelled the atmosphere and went, "That smells like snow"?
I did this past snow. I took a walk and I said, "Oh, it's going to snow tonight."
Yep. There is, and it's hard to describe. I describe it as a heavy smell in the atmosphere, and people look at me like I'm crazy until I actually say, "Smell. See what that smells like?" And it amazes me how many times you can actually pick up that scent, and sure enough, you're going to get some wintry precipitation. Other times is like if we've got severe weather. One of the things that drives severe storms and the possibility of tornadoes is strong upper level winds coming in from different directions. And there are times when I can look up at the atmosphere and I can see clouds just zipping by. And you can see clouds at a lower level of the atmosphere going in another direction. And you can tell that the atmosphere has a lot of energy in it and has a lot of wind dynamics in it. And especially if you can feel the humidity at that time, then you get a pretty good sense that yeah, something's gonna click in the atmosphere and cause something. So there's getting back to the movie Twister. There's that scene where Bill Paxton is dropping dirt and seeing which way the wind's blowing and just kind of looking around. And my wife will look at me if we're watching the movie and she says, "I see you do that all the time." So yeah, if you know what to look for, yeah, it actually works out from time to time.
Oh, so Carrie says, how much meteorology is going out and looking outside versus models and computers?
I think when looking outside, you're basing it on meteorological experience.
Okay.
One of the best meteorologists I have ever known was a guy I went to school with, Dewey Walston. He was a lead forecaster up at the National Weather Service up at Dulles Airport in Washington. And Dewey had this way of remembering different weather events that he had experienced. And I think a lot of being a meteorologist is being able to read what the weather is going to do from experience. That's what computer models do. Computer models look at statistics of other weather events, and that's how they come up with the forecasts. That's why you see that 30% chance of a thunderstorm. Models are looking at past weather events of the last 20 years and going, okay, 30% of the time we had thunderstorms when the atmosphere was doing this. So that's why you'll see that percentage chance of precipitation popping up. And as meteorologists, we also can see the same thing. When we've seen events play out like that before, we'll go, you know what, this is what the atmosphere is going to do. This is the computer model that I think is most accurate. Good example. The winter event we had on Wednesday night, Thursday morning. Like I said, we had computer models ranging from nothing to 9 inches of snow in the Triangle area. We had two models that were seeing somewhere around 1, 2, 3 inches of snow. Well, just looking at the atmospheric setup, looking at the ground temperatures, looking at how warm the atmosphere was leading in, we got in the 50s that day. Sunshine popped out. It was the warmest day we had last week. Looking at all that and the environment that storm was moving into, my feeling just by looking at everything that was coming together is we were going to lean toward about a 1 to 3 inch snowfall over most of the area. And I'm happy to say that we ended up with 1.6 inches of snow at RDU. But there are those times where that forecast goes out in the left field and something happens that you don't expect. It's a big atmosphere out there. And that's the one thing about science. We can have a pretty good grasp on any kind of science, but there's always that possibility that something that can come in from left field and throw our thinking out. That's why you got to be flexible as a scientist. And you've also got to be flexible as a recipient of science information, knowing that things change. Coronavirus is a good example. This was a new virus. Didn't really know how it was going to react. First time I had heard about it was end of last December or end of last January, about a year ago, when my wife and I had the flu. When we first heard about it, and her being a pharmacist, I looked at her and I said, "What's that going to do when it gets here?" And she's like, "We can't say because it's moving into a different environment than what it was in Europe and what it was in Asia." So again, one thing about science and receiving science and using science information is to a certain extent you got to be flexible.
I
You
like
got to
that.
be you got to be able to adjust and shift and work with it.
I like that the application of flexibility. It's just so important in all aspects of our life.
Oh,
I have
absolutely.
I have a question that Carrie posed earlier, which I felt like really fit in now when you were talking about the percentages that we use to forecast for the model, for what's going to happen based on previous data. How much has climate change affected the ability to come up with these models? It's not,
Yeah,
Carrie was asking, have you seen climate change affect things over your career? That was her direct question.
It's amazing that she asked that, because I actually, as I was going through that, that idea popped in my brain. I think sometimes the models are having a more difficult time in forecasting the weather, for the very simple fact that they look back at 20 years of data to come up with those statistics for a forecast. Well, in the recent years, we are noticing more and more issues when it comes to global warming. And statistically speaking, the models are grabbing hold of more widespread data, more temperature spread. Um, that's one of the things that I think is because there's times that I look at the models and I see what the forecast ends up being, and I'm like, they were completely in left field. One of the other things that we generally have seen in the last 15 years, 10, 15 years, and especially in the last 5 years, I believe, the warmer the atmosphere, the more moisture it holds. The more moisture it holds, the more rainfall you can get. And just looking at North Carolina in the last few years, we've been getting a lot of rain. We've been getting serious rain events that have triggered localized flooding. We had one last year in the Four Oaks area where a thunderstorm just set up and dropped 10 inches of rain in like a 8 hour period of time, causing tremendous amount of flooding. When I first moved back, I'll never forget, climatologically speaking, if we were going to get a significant flood event in North Carolina, you generally had to have two back-to-back tropical systems coming in within about a 2 week period of each other. Looking back at 1999, Tropical Storm Dennis and Hurricane Floyd, that's what set that up. That set up massive flooding over eastern North Carolina. Well, in the last 5 to 10 years, it's not taken that. We've had single tropical systems come in and cause massive flooding. And again, I think it's because we've got a warmer climate, warmer atmosphere holds more water vapor for these storm systems to work with. Um, that's I think that's a major concern. That is a major issue right there, especially in the pattern we're in. Because you can look right now on the West Coast. Well, actually, West Coast is seeing a change in the pattern because they're actually getting more rain. But up to this point, the West Coast has been dealing with significant droughts and significant fire threats. And I don't want to complain too much about the wet weather we're having, because in 2007 we had a significant drought where we stayed dry for almost the entire summer, and water supply was getting critically low. We just can't seem to find that happy balance. And the other thing, speaking of the tropics, in the last 15 years, we've had some of the strongest hurricanes on record around the world. And again, that lends itself toward warmer climate, warmer sea surface temperatures, because these tropical systems are getting their energy from the warm waters of the Atlantic. That's another reason why we can see officially hurricane season starts June 1st. Last few years, every time you turn around, we're having a system fire up before June 1st. There's even been talk in the weather world of actually moving hurricane season start date, maybe May 15th or maybe even May 1st at some point. Because there's a lot of times that we do see tropical systems fire up before the official start of the Atlantic Basin hurricane season. And as you guys saw this year, we got into the Greek alphabet. We got deep into the Greek alphabet, and we're setting records left and right for tropical storm formation. So yeah, there's definitely things going on, and there's one graph, if you want to look it up. If you look at the graph of CO2 output, starting with the Industrial Revolution and the atmospheric air temperature, those two curves follow each other perfectly. And anybody who comes up and says that climate change isn't real, that climate change isn't man-made, I was a doubter until about 15 years ago, until I heard of ice cores and the samples of the atmosphere that they were pulling up from those ice cores hundreds of years ago, showing what our atmosphere looked like. You look at that graph and shows CO2 output from industry and into the atmosphere, and the temperatures that we're looking at following that curve. That's a clear indication right there that the atmosphere is definitely warming, and that we need to take a stand, and we need to fix that, because unfortunately, I don't want to say it like this, but I don't know of another way to say it. The planet can fight back. And the atmosphere definitely is fighting back on us right now. And we are definitely seeing a lot more extreme swings in the weather. I think because of climate change and global warming, and we've got to be prepared for that. And hopefully we can fix it over time.
And you are part of our team of scientists who helps us all prepare. So I know we're grateful for the work that you do.
I appreciate that. Any more questions popping up by chance?
So we have Dan asked a question about the Weather Channel, and what do you think about the Weather Channel having the audacity to name winter storms?
I
and
tell you what, you are pushing all my buttons today, aren't you? Well,
and
I will say this, when you name a hurricane, when you name a tropical system, you've got set parameters. You've got a wind speed of such and such. I mean, you got to have 39-mile-per-hour winds with the system to name it as a tropical storm. You got to go to 74 mile per hour to name it as a hurricane. What is a winter storm? What is the winter storm threshold? That's what we've always said. What is a winter storm threshold? Anybody who was in the Triangle area, January 2005, we were in gridlock from a quarter of an inch of snow. Exactly. It took me 3.5 hours to get to work and I had to walk the last half mile. But do you name that? That was an impactful event. Or, what's the threshold? That's always, most meteorologists that I know, that's the thing. It's like, okay, if you can give me a threshold of how bad it has to be, yeah, go ahead and name it. But winter storms impact different regions in different ways. So, yeah, naming them, yeah. When the National Weather Service starts doing it, I'll get on board. But they got to figure out a way to have that threshold first.
I think that's good criteria. Dan agrees. Good point on criteria, Gary.
Yeah.
and um, well, I don't want to have to cut you off mid sentence. We have 2 minutes left, so I feel like we got everyone's questions and comments, and I can go ahead and do my screen share as a final thank you for everyone. Is that all right, Gary? Can I
And
stop your screen share?
and Martha, if you give me real fast, if you're out on social media, which we all are, you can find me on Facebook, Chief Meteorologist Gary Stephenson, on Twitter, gstephenson_weather. And thank you very much for everybody participating and tuning in. And we'll see you on TV.
Yes, that sounds great, Gary. Thanks so much. And I have the thank you for coming slide to share with everybody. We're so glad again that you could join our talk today as part of Astronomy Days. Thank you to North Carolina Space Grant. Thank you again, Gary. You can have a shirt as your hopefully first and only entirely virtual event for Astronomy Days. We'll continue to have virtual components in the future, but this could be your souvenir shirt if you want to join us in commemorating that. But thanks again for joining us for Astronomy Days. And thank you again, Gary. Have a wonderful evening, everybody.